Good afternoon. Welcome to the last class in this module, module 1, and this is lecture number, last lecture, lecture number 48. So this will be the, in this module, this will be the last lecture. Okay? Today will be the last lecture. So today we will discuss the class test question, and the examination was taken on 15th June, and today actually we will actually discuss the solution. So let me write first problem, problem 1. This goes as so that the change in the gives free energy, change in the Gibbs free energy, in the Gibbs free energy for a reversible adiabatic process between state 1 and state 2. Between state 1 and state 2 is state 1 and state 2 with 1 mole of an ideal gas is given by delta G is gamma over gamma minus 1 P2 V2 minus P1 V1 minus S1 T2 minus T1, where subscripts one and 2 refer to states 1 and 2 respectively. Ten marks. So let us quickly solve this problem. Okay, start. Solution. So delta G, it is, if you want to sketch, you may sketch this, no problem. This is your reversible adiabatic. We have actually 100 times we have gone through state 1 to state 2. Now obviously P1, V1, T1, you will remember all changes. And P versus B diagram. You don't have to sketch even, you don't have to sketch. Just I sketch this, reversible adiabatic. PV to the power gamma is constant. Reversible adiabatic. Start. Delta G. Delta G is what we know. Delta G is G is H minus Ts. P2, V2, P1, V1, so G is H minus Ts. Delta G will be what? Delta H minus delta Ts. What is this? Delta H. I'm holding this delta H. Let us see what it comes out. Is what? T2S2 minus T1S1. No trouble. The moment you see this, you are in sight of this. 1 second you have actually cracked the problem. Just see close, close this segment. So this must be then this, but there is a little bit hitch. That is the problem only. That is actually the intellectual part of this. Let us see now T1 S1. Since it is actually reversible adiabatic, S1 is S2. This is the problem. 10 marks credit for this statement, this thinking that S1 is S2. Then the moment S1 is S2, you write there. At the moment you are in smell of this part is okay. Then this must be equal to this. No one can stop it. None here can be stopped. Once this part is over, then this must be this. Then obviously delta H is delta U plus delta PV again inside of P2, P2 and P1. This is 10 marks. So let me complete this. Just I am completing this, okay? A student should approach P2 is, since S1 is chosen, it could be S2 also. The problem it could be S2 any moment. It could be S. What is the entropy? So S is S1 is S2 is S3 is S4 is S5 is S6, including S. Generally applies to everyone. PV to the power gamma is constant is P1 V1 to the power gamma. P1 V1 power gamma is P2 V2 power gamma is the same constant as PV to the power gamma. They are all same. So T2 S1 minus T1 S1. You just say since in a reversible adiabatic process, delta S is 0. You don't have to write ds is dq reversible. You don't have to write so many things. Then you have to say, okay, delta that is S2 minus S1 is 0. That is S2 is S1. So the moment, can I tidy up this? So tidy up it for your satisfaction. Oh, plus T1 S1. So minus, take minus S1, take S1 outside, T2 minus T1. Great job. Who can stop? So delta H. So similarly, delta H is what? Delta H is okay. Like this. Delta H is delta U plus delta PV. H is U plus PV. Minus S1 T2 minus T1. Noting H is U plus PV. Happy? Delta U. We know this delta U is what? CBTT. Delta U is what? CBT2 minus T1. We can write that. NCBDT. DU is NCBDT. So NCB delta T. For which process? DU is Z. This part time. This is Z. This is damn easy. P2 V2 minus P1 beyond. Yeah. This is a food. Tantalizing food given to you. P2 V2 minus P1. Yes, see. P2 V2 minus P1. They are showing. You are very close. 10 marks. How many students? Below 10? 10 they have tasked 7 students out of. Oh, sorry. I should not divulge this. Okay. So this is. So how difficult? 10 marks. So difficult. So difficult to score 10 marks. So let us try. Delta U is what? Du is NCBDT. Why it is so? Vidyut? I am saying du is NCBDT and you are okay? Nodding. Okay? Nodding. Huh? Any answer? Sabosati? Any same answer or different answer? You? The use NCBDT people don't. Same system is ideal gas. No, nothing, anything. For reversible adiabatic, no requirement. For ideal gas is forever. Forever. So ideal gas is such a simple system. If problem is with ideal gas, you will actually just jump at it. Isocore, or don't say so many constant problem you say. Huh? This isocore, isobar, constant pressure. It's a simple thing. Ideal gas, not for reversible adiabatic. It doesn't have to be constant volume. For constant pressure, always NCBG. That should be explained. Some students, many students have not explained this. Not good. But ideal gas, NCBT, because it is a pressure non-constant dependent volume. No, sir, nothing to. Just like for ideal gas, always NCBT, like that. N is 1. Even easier. Ideal gas 1, Cv delta T. P2 V2 minus P1 V1 minus S1 T2 minus T1. Cv delta T. Oh, sorry, Cv delta T. Cv, right? That Cv T2 minus T1. Will you? Plus P2 V2 minus P1 V1. Will you? T2 minus T1. T2 minus T1 in terms of P2 V2. Next round. Tackling the problem. P2 V2 is what? Cv T2 is P2 V2 by NR. The ideal gas equation, heavy, sir. NR is R here, N is 1. P2 V2 is RT2. R minus P1 V1 by R. So it is, food is actually now is served, delicacy is served. And pages after pages, some students actually written, okay, researching on this. And finally ending up with 0. And time is ticking out in the example. So if you actually dig your own grave, who will stop? Happy? Minus S1, shall I complete this? So last line, maybe, or last part 1. Start this part, huh? Is CB by R, P2 V2 minus P1 V1. Oh, there is another one, no? Sorry. I missed one term. What is this? Next one, plus this term, plus P2 V2 minus P1 V1 minus S1 T2 minus T1. So quickly start this place, start. Sorry, T2 minus T1. Sorry. So do it quickly. Plus P2 V2 minus P1 V1 plus minus S1 T2 minus T1. So P2 V2 minus P1 may be taken common. What is remaining there? P2 V2 minus P1 V1, if you take common, which you want, is what? Cv by R plus 1. Is minus S1 T2 minus T1. P2 V2 minus P1. Oh, P2 V2 minus P1 V1. What is this? Cv plus R means Cv plus Cp minus Cv. Cp minus Cv. R, right? R by R. Okay, you may actually. Okay, Cv plus R by R. Okay, minus S1 T2 minus T1. Okay, I don't have space here. I have to give a double star. Sorry, double star. Do this, complete this. Double star. Here, double star. Just like is P2 V2 minus P1 V1. Let us see what it gives, right? Cv plus R is what? Cv plus R is, okay, Cp minus R is Cp minus Cv. Or Cp minus Cv can consider. Anything you can consider. Cp minus Cb, okay? Or you write this here, huh? Cp R, Cp plus Cp minus Cb is the R over R. R is Cp minus Cp. What do you have? Cp by Cp minus Cb, right? Plus, right, S1 T2 minus T1 minus S1 T2 minus T1 is what you just write. It is divided by, I'm just showing you, just playing with this. Cp by Cb, Cp by Cb minus 1. Last line, remove this line, remove this line. Last line is, you get, this is gamma, this is gamma. Or you get this, this was tidy up, gamma by gamma minus 1 times P2 V2 minus P1 V1 S1 proved. You'll be satisfied to write what at the end? Proved. You have no responsibility anymore other than getting the marks, credit. You might say, sir, suppose I miss the clue. I miss this clue. No, sir, suddenly I actually go, so, okay, go astray. And let's do this, let us do this. Sir, you actually, sir, you are prepared, that's why you started like this. But I can, is over, this part is over. Can I remove this? I am removing this, sir. I am removing this. Quickly, alternative method. No, sir, that didn't click, sir. Alternative method. What is this, sir? I don't know. dg is VDP minus SDT, so how about that, sir? Suppose I hook upon this. Suppose I hook upon this, sir. dg is VDP minus SDT, so what problem? Fixed mass mix composition. From G is H minus Ts, this can be obtained. From alternative, G is H minus Ts. I will not show that. This is done in the class. Gives rise to dg is VDP minus SDT. Now you see, if I integrate, just write this and integrate. Oh, we said S. Oh, S difficult. How do you integrate ever? S is a function of temperature. S is a function of etc. No, fortunately for this, S is a constant. Fortunately for this process, S is a constant outside. dt means T2 minus T1. Oh, all set. S is a constant. What value? Constant. So say initial value. Constant. Say final value. So intermediate value, S1, S2, S3, S4, what you are thinking? S1, since given S1. So that is the idea. So integrate this. So or integration dg 1 to 2, integration VDP 1 to 2 minus integration SDT. What I am saying, try to actually unhook a part. So this part I have cracked, means this part will be. It cannot withstand anymore. So what is the good boy? So VDP I am doing this, okay. So it is delta G or delta G, which is G2 minus G1. Okay. VDP is what? I am coming to this integration. Let me correct this. 1 to 2 VDP I'll show you separately. Huh? Easy though, but this can be taken outside. Is minus S T2 minus T1, right first. Is my T2 minus. Then still you write, next you write, since same in a reversible adiabatic process, delta S is 0, that is S is constant. S is constant means, that is S is constant, that is S2 is S1 or S is constant, or S is constant. S does not change its temperature. S is constant throughout this. Now call this, what shall I call? Now it is given S1, but when you have actually understood this, you know, sir, S is S1 or S2. Or I could have complicated this further. S3 I would write. Say, I want to complicate further, confuse you, to check if you are strong and confident. What? I write S3. And you know, S3 is just actually the, S3 is the midpoint of this curve. Between state 1 and state 2 is state 3. If you are smart, S3 or S4, no hanky sir, middle or anywhere between these journeys are, S is constant means S1 or S2 or, so I could have changed more complicated, S3, suddenly introduce S3 on it. And the S3 is the midpoint between 1 and 2. Oh, sir, S3, sir, what shall I do? Half average. I was taking the average perhaps. Alert. So, S1, consider the constant value of S as S1, the initial value. S1, since it's asked, the initial entropy, the entropy initial state, the entropy of the initial state, means it has not changed. Happy? This part is over. I will just show you this part. This side, can I? Now let us do this. See, I will show you this. This part will come as this. This part is okay though. Now let us show now consider the first part. Consider integration VDP 1 to 2. Now here what shall I do? Actually, see, this is actually, you can consider this equation of the path, right? That's right. Pb to the power gamma is constant, is the reversible adiabatic equation of reversible adiabatic path. You have to somehow move to the VDP, V convert V into P. So V is what? Is constant. Call it, give a name. Okay. This actually I used in the reversible adiabatic itself to find the work done. Or V is what, sir? K by P power 1 by gamma. Some students have done this. Not this or this board. So VDP is what? You write line straight. K by P to the power 1 by gamma dP. Pressure is moving from P1 to P2. So K is outside. What is this? Integration of this? P to the power 1 by gamma is what? Integration. Do the integration. P to the power, it is minus 1 by gamma. So minus 1 by gamma plus 1 minus 1 by gamma plus 1. This integration could not be correctly done. So mixed up here. Mixed up. First it is P to the power minus 1 by gamma. Then what happens? P1 to P2. Right? So is what? Like this. So take this outside. K, this is what? 1 minus 1 by gamma. Keep it there. Keep it right. This is what? P2 to the power 1 minus gamma. 1 minus 1 by gamma minus P1 power. This is actually clumsy. This is clumsy, but for where it would be? Shall I? Here. Not much space left. Can I remove this? Yeah, better. Star it. Remove the problem. Solution. Star it. So like this. I know you can do yourself now. Still I'm doing to show you. K is, now you can do, I don't say this much. Now you know everything, You have read in your higher secondary, class 8 you have read, first year. No, I don't say this. So you read here. You may not have read this thing. K is what? So K is just like star it, star K by is just clearly remove this, remove junk. 1 minus 1 by gamma, free, stay cool. This P2 to the power minus 1 minus 1 minus gamma minus P1 1 minus 1 by gamma. No problem. No problem. Now what I am doing, I am just multiplying 1 by 1. 1 by 1 minus gamma instead of K, but here again the same thing is coming. Same thing, forever you remember. This is K is what? P1 power gamma is P2 power gamma. Okay, happy to? It's okay. This equals to this. So K instead of K, what will substitute? Convenient. Well, this will be convenient P2. So what is I'm substituting here? 1 by 1 gamma first term is okay. First term K is P2 V2 to the power gamma instead of K times P2 to the power 1 minus 1 by. Similarly, next K I am writing P P1 power gamma. Okay, this I showed in the reversible adiabatic work done. You may check back. P1 into P1 1 minus 1 by gamma. Happy? Can I remove this line? I think you don't mind this if I remove this line. Will you? No. So what is this? 1 by, what is this? What I wrote here? Hey, you can check this. 1 minus 1 by gamma. 1 minus 1 by gamma. Just copy this. What it is? What it is? And multiply. P2 is working nicely. P2. What is this? Okay. P2 times, what is this? P2 1 plus, what I have made a mistake somewhere. I don't know. So P2 I have removed this somewhere. What it was? VDP too. Oh, actually, this can be done perhaps, but I have gone wrong way. I have gone wrong way. What should I do at this stage? Actually, VDP should be changed. VDP, the VDP should be changed as What is this? See, VDP, if you do this integration, it is getting complicated, but it should also give you the result. Let us let us try this. P2 times 1 minus gamma means, it is 2 minus 1, it is not coming as this, P2, V2 to the power. It is better, VDP should be changed to minus PDP. Let us try. VDP is what? VDP TDS plus VDP. DH is VDP. DH is DU plus round. Okay. I'll check this part. It's VDP. DU plus DW is VDP. DH is DU plus PDP plus VDP is TDS plus VDP. This is DS is 0 and reversible adiabatic process. So this is DW, DQ plus VDP, but this is, I'll check you, I'll give you, just wait a bit. PDB, I think this should be minus PDB, but let us not waste time. What I have done here? No, I'm sorry, it is okay. I went to the DP, this actually should be, but why I made a mistake? Let us start. PP to the gamma is constant, right? To some place. Have I made a mistake here? Gamma is constant. So I have written correctly. Constant is K. K by P power 1 by, correct. 1 by gamma. K by P 1 by gamma. Oh, you have not noted this. What you are doing? You have not noted K to the power 1 by gamma. Is K where? V is what? That has caused okay. Then it is okay. Okay. This is this. V is this. PP to the power, I have made a mistake there. Is K. Is P1 to the power gamma. Write this once more. What else you do? I am very sorry. This actually caused great trouble, delayed everything. K to the 1 by gamma. So that part can be checked also. But don't worry. You will stay here. K to the power, what is the K? Right, K to the 1 by gamma. Nothing you have to do, just write K power 1 by gamma. Otherwise, all same. So go back here. K to the power, otherwise all same. 1 by gamma. What is this? K. Enter the K. What is this? P2, V2 to the power gamma, power 1 by gamma. That means P2 to the power, tell me. Shall I show you separately? You know this very easy. I don't have to know. K is P2 V2 gamma. So K to the power 1 by gamma is nothing but P2 power 1 by gamma times V2. That is right. Oh, sorry. How much time? Happy? P2 to the power K to the power 1 by gamma is P2 to the power 1 by gamma. No gamma, V2 times V2 to the power, as I see. Like this part also, P1 to the power gamma. What I am going to write? Right? Remove this. Write phrase. K to the power 1 by gamma. 1 minus 1 is outside, no problem. K to the 1 by gamma is what? P2 K P2, so P1 rather, P1 times P1 1 by gamma times V1 times P1 power 1 minus 1 by gamma. You please check this. You check this. Repeat. K to the power 1 by gamma is this much. K to the power 1 by gamma is this much. One is in P2 V2, another is P1 V1. Once this is, so keep it there. Okay? It's almost done. 1 by gamma cancel, P2 V2 minus P1 V1. And what is this? Obviously what is this? Gamma minus 1, gamma goes to the substrate. So gamma by gamma, this is not difficult at all. I made a mistake, but it can be PDB, VTP can be shown after. Okay, that I'll check actually. PDB. Gamma by gamma minus 1 is P2 V2 times P1 V1. Hence, remove this, hence delta G, insert this into this, hence delta G is what? Gamma by, this part is P2 V2 minus P1 V1, minus S1, proved. Still, since I should actually I should take it up. Say PDB, VDP. Let us say VDP and PDB. I made a mistake that time. VDP. DG is VDP minus. No, what I started here. S is outside. This part is over. Then what is this? DH is suddenly right, na? VDP. What is VDP? VDP can be written in which form? VDP. Actually, can I answer paper? Once perhaps he made that mistake somewhere. I showed there. Maybe. Where is this? DH is whose? I don't remember. Yours perhaps, I thought. Someone else's. VDP, PDB. So he made, then I showed that how it can be true. Not this. Whose? VDB, PDB? Oh, you wrote, yeah, you go, yes. I showed somewhere. CPDT is VDP. This I showed. Oh, you actually enter into the CPDT form. CPDT. Who else? I don't know. No, not this perhaps, okay. How did you get CPDT? VDP, CPDT, how? You wrote VDP, CPDT. Oh, that's a different thing. VDP, CPDT. Instead of VDP, BDP, it was written as CPDT. No problem. CPDT is okay. BDP, these are the explanations. I'm sorry, BDP. But anyway, so we don't need, we have already solved this. I made a mistake there. But anyway, CPDT. That's actually struck me, so I went through the steps. Okay, very good. Over. Problem 1 over. Problem 2. Problem 2. Any difficulty? Any difficulty? So problem 2. Quickly, problem 2 is about Carnot cycle. Quickly, let us write down the problem. Little bit lengthy, but it will not take much time. A reversible Carnot cycle, you know, heat engine is set up to operate Okay, another thing I tell you, most students, many students, I don't know why they're perhaps, I do not want to indicate anything, the source. They started from the right hand side and went to the left hand side. Okay, and then they have never used that reversible adiabatic character. So no explanation is given, and S is actually written as S1 without giving any explanation. So there are very, and same thing, about 32 minutes, 16 students, same way. Right hand side, starting from the right hand side to the left hand side. Anyway, start. We set up to operate, but this is actually the fair way, and should be the normal way. Okay, is set up to operate with 10 grams, operate with 10 gram mole of an ideal gas. And a monatomic gas. CB is 3/2R as the working fluid. The engine receives receives 150,624 joule of heat at 1200 K. At 1200 K. Sorry. At 1200 K in each cycle, and discharges a portion of this heat at the lower working temperature of 300 Kelvin. A. Find the ratio of the final pressure to the initial pressure. To the initial pressure. To the initial pressure for each of the isothermal steps. For each of the isothermal steps. This is A. Part B is what? Find delta S for the isothermal compression. Find delta S for the isothermal compression. Okay, compression step step at 300 Kelvin. It is 10 marks. I have actually divided into 7 plus 3. Typically, just close to that. 10, first part 7, A 7, B 3 as if. Okay. Entropy part 3, 7. So let us have a sketch solution. Sketch is very helpful in this case because draw this quickly. PV diagram, isothermal, adiabatic, isothermal, 1, 2, 3, 4. This is T1, this is T2. Mark this. And then what is this? 1 to T? T is what? This is actually P1, V1. Write that P1, V1. Write this P2, P2, V2. Write this P3, V3. P4, V4. P4, V4. Okay. And T1 is how much? 1200 Kelvin. T2 is 300 Kelvin. This or T1. Q1, give the cycle with the arrow. This is Q1, you may note this Q1, so-called QH, high temperature QH. How much it is given? 150,624 Joule. This is received. You have to find P1 by P2. This is Q1. This is all given. 10 moles. N is 10 moles. So quickly say, what is this? Let us do this easy way. 150 Q1 150,624. These chalks are not going. 150,624 Joule is Q1 is what? W1. W isothermal is what? You know this value is W1 is nRT1 ln V2 by V1. How difficult? So difficult, very difficult. This is asked. This is asked. Ask P2 and V1 is just this is asked. This question. There is another how many marks? 4 marks here. Only this. I am doing this. I am finding out. 4, 10 first problem and 4 say at least. But I will show that 10 marks also similarly. So 20 marks. The highest mark is not 20. So follow me. Is what? Let us do this. A is 10 sir. R sir 8.314 Joule. T1 sir 1200 sir. ln V2 by V1. Find it out. V2 by V1 is what? It turns out to be, let me give the calculation. V2 by V1. Don't mind. V2 by V1 is actually, if you do this, and I tell V2 by V1. Okay. V2 by V1 is what? Is also is V2 by V1 is P1 by P2 is what? 4.53. 4.53. V2 by V1 volume has increased. Factor 1. V2 by V1 is known as what? Or P1 by P2 is what? P1 V1 is P2 V2. Remind P1 V1 is P2 isothermal part. So P1 4 or P2 by P1, what is asked? Final is to initial each isothermal. Final P2 initial. P1 by P2 is 4.53 or P2 by P1 is 1 by 4.52. Do you know this? 1 by 4.52 is 0.22. And that's it. Answer. But another isothermal is there. This is over. One is out. For each of the isothermal. Here heat you can find out. But you don't have to. Another trick is there. Even easier. You should note that. Note next part. Next part is not actually complete. Next. Next what? Shall I give this? Start. What I am saying, do you know this? V2 by V1, follow, V2 by V1 is V3 by V4. V2 by V1 is V3 by V4. V2 by V1 is V3 by V4. This is already shown in the class. Already shown in the class. Carnot cycle first day. This was shown. V2 by V1 is V3 by V4. V3 by V4 is what? V3 by V4 is what? Tell me. P4 by P3. P4 by P3. P4, what is asked? Final is to initial. P4 by P3 is V2 by V1. What is the V2 by V1? 4.53. Or P4 by P3 is 4.53. Answer. You don't have to find this without finding this. Do you remember how it is done? So it is 8 marks, 7 marks, 17. 17 marks already. Question 3 you have not touched yet. Question 2. And remember second part is coming. So see, I will show you, just you will be surprised. This value we just play with this. See, first line, second line, third line. This is one answer, this inverse of this, one answer. Other answer exactly this itself. A third answer I am showing. So this, about this, 10 marks. Okay, moreover I will tell you another thing. Actually, why, this you already shown in the class, can you know how? Do you know how? This is I am saying, you see clearly see, V2 expansion, here greater volume, V3 is greater volume. So V3 by V4 is V2 by V1. This is how it was done. Time is okay, wait a minute. Oh, don't worry. So this is actually what? So you see, you follow. You have not able to solve this. Otherwise, what you do actually? Time is what? I will not come here. Even you request me, I will not come back. So you take your time. So you have to give me time. Okay, you started late. So double start. You can leave actually. Those who are impatient can leave easily. Okay, just you stay back actually for the recording. Okay, this I have to complete this. But you can go easily. The star is okay. Because double star is how it is proved. See, you cannot answer. You have no interest to how it was done. Sir, 20 marks, 10 and this is only this. The whole problem here. Either inverse here and exactly that. A over. B also coming in the same manner. And 4 pages. Oof, so many pages. First of all, you know how it is true. Considering the adiabatics. 2 to 3 adiabatic, 2 to 3 adiabatic, reversible adiabatic. And I am giving a clue I am giving. I already gave you in the class. Okay, reversible adiabatic and 4 to 1. 4 to 1 reversible adiabatic. You know what is this? What will get? 2 to 3 adiabatic applied. Tp to the power gamma minus 1. T is what? 2, 3. 2, 3 reversible. What is the temperature here? What is the temperature here? 2. What is the temperature? T1. It is under T1. T1, write that. T1, Tb to the power gamma minus 1. B2, gamma minus 1. This point, what is the temperature? What is the temperature? T2. T2, what is the B3? Gamma minus 1. It's 1 down. And next is what? And similarly, and again apply here. Right, tell me here, 4 to 1. Apply here. T1. What is this? This adiabatic. T1, B1 to the power gamma minus 1. What is this? This temperature T2, V4 power gamma minus 1. So get T1 by T2 from this, T1 by T2 and T1 by T2 same, you get back. Actually, you should show this also. In case that you have doubt or you can explain this. This two gives you, okay, from T1 by T2, get T1 by T2. So these two problem over, last is what? Delta S. Oof. Or this much place is required. This much. Delta S is what? Last part. Part B. Yes, I'll show that this much space. Though I can remove this, but I'll show here. Part B. Delta S is what? NR ln V2 by V1. Isothermal path. Delta S for which step? 3 to 4. It is given. Delta S 3 to 4, write that. Isothermal. Write this isothermal. Isothermal, you know what is the relation? Isothermal, you start from the scratch, dq delta is q reversible by t, do, or you have formula nr v2 by v1. What is v2 by v1? nr ln, oh, no, last step, 3 to 4, and v4 by v3. v2 by v1 general name, but it is v4 by v3. v4 by v3. What is v4 by v3? Let us take a look. v4 by v3 is actually v1 by v2 is nr ln v1 by v2. As I told you, it is about v2 by v1. So what it is? v1 by v2. Okay, see here. v4 by v3 is v1 by v2. What is this? Minus, tell me, minus nr. I cannot. ln, what is v1 by v2? Tell me, v2 by v1 is this. v2 by this inverse, 0.22, 0.22. ln 0.22. How much it is? N is how much? Actually, I'll show you. N is 10. R is how much? I want to confine here. 8.314. ln 0.22. How much it will turn out to be? Shall I? A little bit extended. Okay, better you write here answer is, I am giving the answer, minus 126 joule per Kelvin. 100, this term may not be important anymore, minus 126 joule per Kelvin. This is about 10 marks. 10 marks here to here. So I said only this. How you can obtain this? If you wish, you can find out the heat here. Then apply. That is possible. About this heat relation, this heat by this temperature is this heat by this temperature. That is possible. Then find the heat, again go by the same similar type of relation. Possible. Possible. But even easier. Possible. That is. So answer is answer. Right answer. So over problem 2 over. So I wanted to confine here, so I didn't actually write any. Okay. Okay. Another place for character. Remove all this. Last problem. Last problem is actually another problem is this. Problem 3. Quickly write this problem. 1 mole of adiabatically content liquid gold is supercooled to 1223 Kelvin. It was found that 26% of the gold spontaneously freezed out when the process is stopped. When the process is stopped. Happy? Okay. Find the entropy change. Change of the system in the process. in the process. Data given, data given 1 Cp of gold liquid, 29.3 kilojoule per or joule per mole, joule per Kelvin, joule per K mole, delta Hm gold at 1336 Kelvin, 12,760 joule. Third point is melting point of gold, 1336 Kelvin. So let us quickly, this is actually very sad to say, very disappointed to say that this problem was solved in the class, not as assignment even. In thermochemistry last class. When adiabatic flame temperature is over, let us practice problem. Exactly this language. Only one thing, this was unknown there, it has been made known for your benefit. If you have to calculate this, then that will be another phase, another step, repetition of that though, but first you have to, but you don't have to. But find the entropy change. State 1 to 2 enthalpy can be found, entropy change can be found, diffuse energy can be found, any problem can be set. So what I will write, it was already written, but still I have the solution. What I said there, I am writing. Here 1 mole gold liquid, what temperature it is? 1223. Goes to what? Solidified partly, and remaining liquid is at that temperature, freezing temperature, no more freezing. So this is below freezing. So freezes to how many? Okay. So 26% is 0.26 mole gold solid. What temperature? 1336 is reached. So what is happening? It is freezing. In the meantime, temperature increasing because adiabatic. The heat has not come out. Heating up. Temperature increasing. The moment it hits the melting point or freezing point, which is 1336, stops. By that time, 26% has been solidified. The remaining is 74%. 0.74 mole has not yet converted. Gold liquid, hot temperature 1336. So it will not be freezing anymore. So the process stop. Even though I don't give, it will process or automatically discontinuously. Overall reaction, overall process or reaction or process. The overall process breakup. Quick breakup I can tell you. Easy breakup. Okay, say A. 0.26 out of this, say as if divide by two parts, 0.26 and 0.74. Take up 0.26 gold liquid. Easy breakup. Gold liquid 1223 Kelvin goes to, okay, what is the overall this? 0.26, take it to 0.26, I'm very sorry, 0.26 gold liquid itself, 1336 Kelvin. First step. Second, B, take this 0.26 gold liquid, 1336 is the time now for being frozen. So 0.26 gold solid. This is the freezing point, normal freezing point. Last part, obviously 0.26 is addressed. What is not addressed? 0.74 gold liquid 1223, which I have not addressed. 0.74 will go to 0.74 gold liquid 1336. You can check easily. You can check. I can show you here. If you hand it together, friendly cancel this. This you have written here. So what you are getting? This one back. Right hand side you are getting 0.26 gold solid. Yeah, 1336. So, but you don't have to cancel. You have this. Next is now. See, these A and C together same. This is 1223 liquid, 1223 liquid. 1336 liquid, 1336 liquid. So combine. So even easier. Combine, you may not combine. You just go on. It will be three-step breakup. Now combining A and C. This was in the class. What am the class? Note. See, exactly this. Now combining, but in the thermochemistry, okay. But knowledge is knowledge. But now combining A and C, we get a two-step. Breakup. How quickly combine and finish this. 0.26 and 0.7 is 1, so call it 1 now. ABC, instead of ABC, 1. So 1 gold liquid, 1 mole, 1 gold liquid, what temperature? 1223 Kelvin, goes to this side is 1 mole gold liquid, 1336 Kelvin. This is all 1 atmosphere also. The pressure is condensed phase constant. Okay. And what is the remaining plus this step B? 0.26 gold liquid, 1336 K goes to 0.26 gold solid, 1336 K. Over these two, you get the delta S. So start it and complete this. Now delta S 1 by 1. What is this? Heating type, sir. Enthalpy heating type CPdT, and entropy CPdT by T, sir. This constant pressure process. Okay, so condensed phase. So CPdT by T. What is this, sir? 1 mole. So 1 is very easy. CP gold liquid dt. If it is enthalpy, CPdT by T. Integration 1223 to 1336. Shall I complete this quickly? CP gold liquid is how much? 29.3 perhaps. 29.3. Sorry. Times dt by T is ln. If it is dt, T2 minus T1. But if it is dt by T, ln 1336 by 1223. Happy? Then I can give the result. I give you the result. Interesting result is 2.59 joule per Kelvin. In the class practice problem, I found this CPdT as enthalpy. Now it is entropy. Delta S2, can you tell me what is this? Delta S2? It is a freezing process, okay? So it is what? Delta H freezing, but we have delta HM data, so make it minus delta HM there. By what is the temperature? Which temperature it is? 1336. Just this. What is this? Write this again. Minus 30. What is the value? 1276. 12760. 1336. It will be what value? It will be, if you do this, minus 2.48. Or delta S total, delta S system process is delta S1 plus delta S2 is what, sir? 2.59 minus 2.48. 2.48. How much it is? 0. Plus, you may there plus 0.11 joule per Kelvin. Sorry, sir. Sorry, this is not good. This is 0.11. Should be written. I can write this. Somehow I always answer. You write your answer. Means you relax. This is the 0.1 joule per Kelvin. Achha, now question whether this positive. This positive value, does it indicate anything? No, you see, what is the rule? Rule is rule. Delta is inverse. This is delta system, but since it is an isolated adiabatic system, delta surrounding does not take part, doesn't know. So delta surrounding is 0. Delta system is this plus, delta inverse is plus, as is expected of a spontaneous process, okay, spontaneously. Okay, this concludes everything. Okay, this was another. I am giving this. This is also 10 marks. Note that. So 30 marks. So this over, huh? No, no, you stay back for I have actually see. Just I need 5 to 10 minutes. Okay, I have something to say. Okay. Can I remove this? Everyone, is okay with you? Huh? So remove this. So I am saying something. Okay, at the end of this class, okay, this is recorded. This is being recorded. So, today's class is hereby concluded. What I say, but note. However, note these how many? This that's quick. Yeah. This first module. Just let me write few comments there. This will be helpful for everyone. This 48 class, 48 lecture, module 1 classes, module 1 from start 25th of first March 23rd 2023 to today's date is what? June 19, 2023. So, however, this 48 lecture model 1 has not covered many subsequent important topics. Namely, quickly, I'm giving some names. This is required. Then I will write one line. One is quickly, that is fugacity, right? Behavior of real gas. Right? This fugacity and compressibility. Quickly, just topic name, compressibility. Then second, fugacity, activity, and equilibrium constant. Third, graphical representation of gives free energy of the minimization of gives free energy at equilibrium. Fourth is establish of the relation delta G0 is minus RT ln K. Fifth, effect of pressure, temperature and pressure on equilibrium constant. K and constant, K and equilibrium composition. Right here in this Van 't Hoff equation, that is Van 't Hoff equation for temperature and Van 't Hoff equation, okay, for okay. Acha. Also write Law-Chatelier principle. Law-Chatelier principle. 4, 5, 6. 6 would be here. 6 this side. 6. 6 is what? Variation of delta G0 with temperature. General expression for the variation of delta with temperature, 5 terms, containing 5 terms. Next is C7 Ellingham diagram. And relative stability of oxides. Of oxides. Phase equilibrium. Phase equilibria, single component. Single component. What is this called? This equation is Clausius-Clapeyron equation. Clausius-Clapeyron equation. 7. What is it? 5, 6, 7, 8, 9. Solution thermodynamics. Solution thermodynamics. It contains this Raoult's law, ideal solution, and non-ideal solution. You star here, double star, remove this here, just here, double star, activity coefficient, Henry's law for dilute solution. Then what? Mixing properties, mixing functions, excess functions, gives Duhem equation. Finding partial molar property from integral property, from the integral molar property. gives 2m equation and its integration. And its integration, what else? That is solution model. Regular solution. Right? Alternative. Next is 9. 8, 9 so far. 10. Alternative standard states. Standard states. Henrian. 1 mole fraction and 1 weight percent. And interaction coefficients. Ten, 11 gives phase rule and construction of stability diagrams. That's okay. All these diagrams, all these topics may be covered in the second module of video lectures. If recording facility and students participation and administration cooperation are available.